Hi everyone, welcome to this next video. So in this one, what we're going to look at doing is going through the style of questions that you'd see in a paper 2. I've kind of picked topics that are quite likely to come up. So worth looking at these. I'll put timestamps in the description as well. So if you look at the headings I put here, you could skip to that question if it's something you know you struggle with. So I'd suggest what you do as well is you pause the video and try and answer the question, then unpause it, and then double check that you are correct as part of your revision. Okay, so we'll jump straight in now and start looking at the first few questions. Okay, so first question here, it says convert 8,400 meters to kilometers. What you should know is that 1,000 meters is equal to 1 kilometer. So in this case here, 8,400 will be 8 point something, so it's got to be 8.4 kilometers. Okay, so 1,000 is 1, 2,000 would be 2, because it's 8,400, it's 8.4. Okay, question 2. So what we're looking at is ordering our fractions here. The first thing you need to do is make the denominators the same. So we've got 4, 3, 12, and 6. What you need to think about is what number do all of these go into? Well, I can make them all to 12. So how would I do that? Well, I times this one by 3. I then would times this one by 4. And I don't times that one by anything because it's already 12. And I would times this one by 2. So when you do that, this would be your first mark that you would get. If I times this by 3, I times the top by 3, so it becomes 9 over 12. The second one becomes 4 times 2 is 8, so it becomes 8 over 12. I'm leaving that one the same, so that's staying as 11 over 12. And then this last one here becomes 10 over 12. So that would be your first mark for making the denominators the same. Then all you need to do is put it in order from smallest to biggest. So you can see here that the 8 over 12 is the smallest. So you don't write 8 out of 12 over 12. What you do is you actually write the original fraction. So I've done that one. Next one. So the next one is the 9 over 12. So again, I don't write 9 over 12. I write 3/4. Then I know the next one's the purple one, which is 5 over 6. So I write 5 over 6. And then the last one is the 11 over 12. So that is in order from smallest to biggest. I picked up a mark for making the denominators the same. And then I picked up my second mark for putting them in order from smallest to biggest. Okay, next one here. We would have a calculator available for this anyway. So you could write it out like this. Okay, because cubed means times by itself 3 times. So it's 4 times 4 times 4. Or you could just, on your calculator, just very simply type that in. Now, 4 times 4 is 16. 16 times 4 is 64. So your answer would be 64. As it's in a paper 2 there, just double check, use your calculator to make sure you are correct. Okay, okay, question 4, factors. So we should know that a factor is a fact of that number. So it's part of that number. Okay, so you've got to think about what goes into the number here being 32. A multiple is when it gets bigger and it multiplies. So a multiple multiplies, it gets bigger. A factor is a fact of that number, so it's smaller. So what you're looking at is what numbers multiply to give you 32. Well, you've got 1 times 32. You've got 2 times 16. 3 doesn't go into 32. You've got 4 times by 8. 5 doesn't go into 32. 6 doesn't go into 32 because it goes into 30. And then you go 7. 7 doesn't go into 32. And then because I've got to 8, I can stop back at 8. Then from here, because I've now got back to the 8, these are all my factor pairs. So I then write them in order. So I can say 1, 2, 4, 8, 16, and 32. They are all my factor pairs. They are all the numbers that would multiply to give me 32. Okay? So let's scroll down, starting to look at question 5 now. Just going to zoom in a bit so you can see a little bit clearer. Question 5 says round 4.876 to 3 significant figures. Now, a significant figure is different to a decimal place. A significant figure is the first number that is not 0. So in this case here, that is my first significant figure. So that's first, that's second, that's your third significant figure. So what you do is you underline the significant figure, you draw a dot after it. What does the 6 do to the 7? Well, if it's 5 or more, it pushes it up, okay? So in this case, the 6 is above 5, so it pushes 7 up, so it becomes 4.88, okay? Because that 7 moves up 1. If the 6 was less than 5, it would just keep it as a 7, okay? So just remember, a significant figure is different to a decimal place. A significant figure is the first number that is not 0. Next question here, a box of 48 pens costs £6.85. So the first thing I do is write down what you know. So 48 is equal to £6.85. Then from there, I've got to buy 763 pens for a school. Keyword here, it says estimate, which means we need to round some stuff here. So if I need to buy 763, what I can round that number to is 800. So I've got to buy approximately 800. Now, if it's a box of 48, I could say that's approximately a box of 50 pens. And if it's £6.85, I could say that that's approximately £7. So all my values there I've rounded. Okay, so that has turned to 50 is equal to £7. Now, what I've basically got to work out is how do I get to 800 here? Well, 50 to 800, I've got to think about what I need to times 50 by to get to 800. So you could do 800 divided by 50, or using your understanding, you could figure out that that is times by 16. So if I'm then timesing that by 16, I'd have to times the 7 by 16 as well, and that gives me £112. So my answer to this, as an estimate, would be approximately £112. That's how much it cost me to buy those pens for the pupils in that school. Okay, moving on, question 7 now. We're looking at a stem and leaf diagram. Okay, key thing here as well, it says it's got to be an ordered stem and leaf diagram. So the following shows the weights of 15 rugby players in kilograms. Key thing here as well, we've got 15 pieces of data. So we need to make sure I've got 15 pieces of data in the stem and leaf diagram as well. Okay, so to do this, the first thing I would then do is I would draw a rough version of my stem and leaf diagram here. So looking at this, I'm going to look very quickly at what is my smallest amount. So I've got 75 as the smallest. If I move along, I'm still looking, and 75 is my lowest value. So I know 7 is going to be there. I've got values in the 80s, values in the 90s. I've got values in the early 100s, and I've got 110 and 120. So they're going to be my stem. Okay, so that represents my tens. What I then do is just go through the list and write them down. So 75, 82, 96, 110, 85, 94. So you can see straight away now that this is out of order, but what I'm going to do is once I recopy it, I'll put it in order. 115 goes there, 111 goes there, 120, 99, 88, 112 would go there, 80, 105, and 96. So I know what I've done is I've gone through and put all those pieces of information in that stem and leaf diagram. What I now do is I go back to my neat version and I put my stems all in. So that represents 70, 80, 90, 100, 110, and 120. So that's my stem put in nice and neatly. Then what I do is I go to this and I put these bits in order. So there's only one value there, so 5's fine. Then this goes 0 to 5, 8. You want it to be in order, 0, 2, 5, and 8. I know I've done that. Smallest number here is a 4, so I go 4. Then I've got 2 6s and a 9. So I know I've done that. There's only one value there, that's the 105. The next one goes 0, 1, 2, and 5. So that's all good. And then the 120. So by doing that, you know you're not making any mistakes and you've got everything ordered in the correct way. Now in the exam, you could then just put a line through that so you know that that's your incorrect version. And then a stem and leaf diagram is going to be worth 3 marks. So the last thing you've got to make sure you have is a key. So what you do is you pick one of the values from here. So it doesn't matter which one I choose. I'm going to choose the 7. Then you put the line that is there. So that represents 7, then with the line. So that's your stem there. This is the leaf part. And that represents 75. And that represents 75 kilograms. Okay, so you must make sure that you've got that key as part of your stem and leaf diagram as well. So a stem and leaf diagram is worth 3 marks. 1 for getting that bit correct, the stem. This bit here is the leaf, which is ordered from smallest to biggest, and your 3rd mark for the key. Okay, so it then says find the median. So you need to understand what median means. This is your middle number. Okay, now in order to find the middle value, there's a couple of things you could do. You could cross out the smallest bit of information. So you could cross out the 75, then cross out the biggest, next smallest, next biggest. And then what you do is you'd carry this on until you get to the middle number. So smallest, biggest, next smallest, next biggest, next smallest, next biggest. You just got to be really careful to make sure you get the right way around. Or what you could do is you take how many pieces of data there are. So pieces of data. So in this case, there are 15. You add 1 and divide it by 2. So it's 15 pieces of data plus 1 divided by 2 is 16 divided by 2, which is 8. So what you're looking for is you're looking for the 8th number in this list. So that's the first number, second, third, fourth, fifth. Then you go back here, 6th, 7th, 8th. So this is actually your median. Now, please be really careful here. Do not write down 6 because 6 is not the median. It is 96. So the median weight of those rugby players is 96 kilograms. Okay, so that's how you do your stem and leaf diagram, and that's how you read the information off of it as well. If it was between two numbers, so let's say it was between 96 and 99, all you would do is go in the middle. So you add the two numbers together, so add 96 and 99 together, and then divide it by 2. Or what you could do is just work out there's a difference of 3 there, and the middle of 3 is 1.5, so you'd add 1.5 onto there, and that'd give you 97.5. Okay, so that's how you'd find stem and leaf diagrams and the median. Okay, next one we're looking at here is pictograms. So I'm just going to zoom out a bit so you can see. So it says the diagram shows the number of minutes Sarah spent on her phone per day in 1 week. So looking at this, we've got to understand what the keyword means. So one of these phones represents 40 minutes. So what I would do straight away without even reading the rest of the question is I'd write down how many minutes we've got here. So we've got 40, 40, and this half a phone would therefore be 20. So that's a total of 100 minutes. Okay, we don't know this one. The next one, we've got 40, 40, 40, and 40. So that's a total of, you can write it out in 4 if you want. So that's 160 minutes. We obviously don't know Thursday. And then we've got 1, 2, 3, 4, 5, 6, 7 lots there of your 40. So you could either just do 7 times 40, or you could do 40 plus 40 plus 40 7 times. So I know that 7 times 4 is 28. Put your 0 back on. And then here, how many have we got? 1, 2, 3, 4, 5, 6. So 6 times 40 is 240. Again, you'd have a calculator for this, so you could use a calculator. 2, 3, 4, 5, 6 there. So that's 6 full lots times your 40. So that's 240 again, but then you've also got this 20. So we know that that one is 260 minutes. So that's the first thing I would do. I just write down the pieces of information that you know. So it says Sarah spent a total of 1,240 minutes in the week on her phone. So let's use that information now. Well, what I can do is I can look at the fact that I've got my 100 minutes here, I've got 160 minutes here, 280 here, 240 here, and 260 here. So in total, if I add all that together, so we're doing all of those added together, when I do that, I get an answer of, so when I do that, I get an answer of 1,040 minutes. So in total, that's what I've just got. I know that the whole thing is 1,240. So therefore, I haven't even read the whole question yet. I'm just figuring out things that are left over. What can I work out? What can I actually do with the information I've got? So I can now say 1,240 minutes is what she spent in the week, minus the 1,040. And that leaves me with a total of 200 minutes that need to be filled on this pictogram. So Sarah spent a total of 1,240 minutes in the week on her phone. The ratio of the minutes spent on Tuesday to Thursday was 3 to 2. So I know that there's 200 minutes that need to be filled in on this pictogram, and the ratio of how she spent it was 3 to 2. So that's a total of 5 ratios. So what we've got here is a pictogram question linked to ratios. So 5 ratios has to equal the 200 minutes. So 5 ratios equals 200 minutes. So what you want to do in any ratio question, you want to find one ratio. So I divide that by 5. When I divide that by 5, I have to divide this side by 5. So that gives me a total of 40 minutes. So one ratio would be 40. And remember, I know here that what I've got is this 3 parts here. So 3 parts times by 40. And then here you've got your 2 parts times by 40. So in total, that would be 120 minutes on the Tuesday and 80 minutes on the Thursday. So they would be your 2 things you need to do. What you then need to do is complete the pictogram. So I go back to here, and what I then need to do is I need to draw 120 minutes worth on Tuesday, so that's 120, which means I need to draw 3 phones. So I'm going to just take a bit of a shortcut here. I'm going to copy these 3, paste them there. So there's my 3 phones for that Tuesday, because that represents 120 minutes, and I've got 80 minutes for the Thursday, which means I then need to do 2 phones because it's 80 minutes for that. So I'd cross out that last one, and that represents my 80 minutes. Okay, so that's an example of a pictogram question. Use the information you've got, work out what you can, and go from there. So next one, moving on, question 9. We've just got a really simple question here where it says work out the value of something. So what we're going to do is we're going to get a calculator up, and I'll show you just how you type this in on a calculator. Okay, so hopefully you can see here on the left hand side, I've got the just a Desmos calculator up. So the first thing is when you see here on your calculator in your exam, you just need to remember that it's a fraction. So you're looking for that fraction button there. This is the top right hand side for me. Just down here on that top right hand side, you can see it says A over B. On your calculator, you want to make sure you find the fraction button. Then it's a case of just typing everything in, but making sure you type it in properly. So it's 7.21 squared. Then it says plus, so I'm making sure I put my plus, and it's got brackets. It's 9.4 minus 2.32. Make sure I close my brackets there. And then at the bottom here, this, making sure here it's cube root. So for me, it's an n with the little root sign. And then inside it, you're typing in 8.72. So I'm typing that out in full. I'm writing everything down on my calculator, and I double check to make sure I've got my squared there, which you can see, and I've got my cube root there. Everything's all nicely and tidily written. So it says here, write all the figures on your calculator display, which means what you need to do is write the first page, basically. So in this case, it becomes 28.69578. 578407. Okay, so it's basically just the first. If the calculator display ends up going on for a long time, you can just write the first page that you get on your calculator. So a lot of the time, this question will then be followed with write your answer to 2 decimal places or significant figures, etc., etc. So 2 decimal places here. That's my first. That's my second decimal place. So what you need to make sure you do, let's just write the number out of Kim, because I want to make sure I'm not going to make a mistake. So double check. 28.6957847. So 2 decimal places means that's my first, that's my second. I draw a line after that. What does this 5 do to the 9? Now, remember, if it's 5 or above, it goes up. So in this case, that 5 pushes the 9 up, which means it's going to push it up to 10, which means it pushes this up to a 7. So this, instead of being 69, this becomes 70. So in this instance, this becomes 28.70 technically, because that 9's turned to a 0, but you can then put your answer as 28.7. Okay, so it's really important that you're really careful in rounding that properly. Just make sure if it says decimal places, it's the places after that decimal. Remember, 5, 6, 7, 8 or 9, it rounds the number up. If it's 0, 1, 2, 3 or 4, it will keep the previous number the same. Okay, so let's move on to question 10 then. I'll make this bigger again so we can see it a bit clearer. Billy has a fish tank as shown in this diagram. He's going to fill it with water, so it's 70% full. So a key piece of information there, it's 70% full. Now, because we're filling something up here, we're talking about volume. Okay, so I'm just going to kind of be aware of what it is we're talking about. Volume is the space inside the shape. Okay, work out how many litres of water Billy needs. So this information here is really important. 1 centimetre cubed is actually equal to 1 milliliter. And it's talking about litres. Now, litres is 1,000 millilitres. So you need to make sure you know that as well. So we've got a bit of conversion going on. Okay, first thing, let's work out the volume. So to find the volume of any shape, you find the area of the front face. Now, the front face in this is a rectangle. So I'm going to do 60 times by 80. Now, I can do that without a calculator, but if you want to use your calculator, you can. So 6 times 8 is 48, and then put my 2 zeros back on. So that's the area of the front. And then what you do is you times it by the depth. So then I'm timesing that by 20. Okay, well, I'll do 48 times 2, which is 96, and then 1, 2, 3 zeros. So that becomes 96,000 centimeters cubed. I've just picked up a mark because I've identified the questions about volume. So this fish tank has a total volume of 96,000 centimeters cubed. Let's read the next part. It's going to fill it with water, so it's 70% full. So I now need to find 70% of 96,000. There's a couple of ways you could do that. You could either find 10%, times it by 7, or because we've now got a calculator, you can just turn your 70% to a single multiplier, which is 0.7. So then we're saying 0.7 times by 96,000. Okay, which is probably an easier way of doing it. But however, if you're confident finding 10%, so divide it by 10 and then times it by 7, that would be absolutely fine as well. When I do that, I get 67,200 milliliters or centimeters cubed. Okay, because remember 1 centimeter cubed is 1 milliliter, so I can actually now turn this back to milliliters. So what I'm saying is, when I fill this up with water to 70%, up to this kind of level here, what you end up having is 67,200 milliliters of water. It says how many liters of water does Billy need? Well, we know that 1 litre is 1,000, so your final step is to then divide that by 1,000. Again, if you wanted to use your calculator just to double check yourself, that's absolutely fine, because we've got the calculator in this. It will be 67.2 litres. Okay, if you're dividing by 1,000, we're technically moving the value across, and you could cheat and use the fact that you're moving your decimal place 3 places. Okay, so the answer to this question would therefore be 67.2 litres is what he needs. Probably be worth 3 marks in your exam. Okay, so moving on now to question 11, we've got a bit of a speed, distance, time question, because I can see here that is my distance. I can see here I've got speed. So therefore, the first thing I'm going to do is write speed, distance, time. Make sure you get it the right way round, and make sure you've got distance at the top, speed and time at the bottom. So what I'm actually going to say to you is, when you have a question like this, where you've got Amy cycles 15 miles at an average speed of 12.5 miles per hour, and she then cycles another 90 minutes at an average speed of 12.8. There's 2 parts to this journey. When you have something like this, what I suggest you do is a 2-way table. So you've got speed, distance, time. And we've got part 1, and then we've got part 2, and then we're going to have a total. Okay, and by doing that, it just helps you organise the information and see which pieces of information are missing and what we can find. It will also help you pick up marks and make it really easy for an examiner to see what you've worked out and where you've worked it out. So let's just fill in the information that we've got. So I've got here, Amy cycles 15 miles. That is my distance at 12.5. So straight away I can see the time is missing. She then cycles 90 minutes, so that's the second bit. I'll do that in a different colour. So 90 minutes at an average speed of 12.8. Now what a lot of students here do is they add these two together and then potentially divide it by 2 to get the total speed in that essence there. Now what you need to remember is, this is asking you for overall average speed for the entire journey, which would be total, because when you think about speed is equal to distance divided by time, so it's total distance divided by the total time. And it's really important you understand it's those totals, okay? So let's figure out this first bit. What we're missing here, we're missing time. Well, to find time, it's distance divided by speed. So what you're therefore going to do is 15 is distance divided by 12.5. And when you do 15 divided by 12.5 on your calculator, you'll end up with 1.2. Okay, so what that's saying is it's 1.2 hours, because that is my distance in miles and that is my speed in miles per hour. So that means it's 1.2 hours. Now 1.2 hours, what you then want to do is times that by 60, and that will give you your answer in minutes. So that is 72 minutes, okay? Or you could remember that 0.2 is 20% of an hour, and 20% of an hour would be 12 minutes. The next thing you then need to think about is what's missing in part 2. Well, part 2 has got distance missing, okay? That's missing there. How do I find distance? Well, it's speed times time. So what I'm saying is 12.8 times, and I need to be really careful, it's not times 90, because actually this 90 minutes is equal to 1.5 hours. The reason I have to turn that into hours is because this speed is in miles per hour. So therefore you're doing 12.8 times 1.5. Okay, so it's really important that you understand that 90 minutes, you can't just times it by 90. You need to make sure you turn it into how much of an hour. 90 minutes is obviously 1.5 or an hour and a half. When you do that, you get an answer of 19.2. So that's in miles. That's in miles. I can now start to put things together, okay, because we've got the distance there, which is 19.2 plus 15. So we've got a total of 34.2 miles. And now I need to add these times together. So you've got 90 minutes plus 72 minutes, which is 162 minutes. Okay, so final thing here, we need to find the speed. We said over here to find the total speed, the overall average speed, sorry. We're going to do total distance. Well, we've now got that. That's 34.2. And divide it by the total time, which is 162 minutes. Now, what we need to be careful with is that when we do this, this is going to give me my speed in miles per minute. So 34.2 divided by 162 gives you 0.21 reoccurring. But then that's per minute, so you need to times that by 60. And when you times that by 60, you end up with an answer of 12.6 reoccurring. So it's 12.6 reoccurring miles per hour. So the hardest thing with speed, distance, time questions is remembering that the time needs to be turned into decimals. So 90 minutes being 1.5 and 1.2 hours is not 1 hour 20 minutes. Making sure that you know that 1.2 is actually 1 hour and 12 minutes because 20% of an hour is 12, 10% of an hour is 6. And then the final bit here, just remembering that overall average speed, you need to do the total distance divided by total time. Okay, so moving on here now, we're going to a bit of shape. So we're talking about the fact that this is a triangular prism and it's asking you to find the volume. Okay, so to find the volume of any shape, as we spoke about in that fish tank question, you find the area of the front and then you times it by the depth. So if we look at this question, the front is a triangle, which is base times height divided by 2. So in this case, the base is 11.6 and the height is here, which is missing. So straight away, you should be thinking to yourself, there's a triangle involved. This would be a right angle. I'm going to need to use Pythagoras. That is the shorter side. So what you need to do is reverse Pythagoras. So you're going to be doing 18.4 squared. So to find the shorter side in Pythagoras, you square, you subtract. So 18.4 squared, which gives you 338.56. You do 11.6 squared, which is 134.56. So you're doing the 18.4 squared minus the 134.56 squared. When you do that, you get a total of 204. Then you need to remember to square root that. So the square root of 204 is 14.2829. Now, because we're going to give our answer to 2 decimal places at the end, I'm going to keep this to 2 decimal places here. So that becomes 14.28. So I can now say that this is my height, 14.28. And what I now need to do is find that area because I can now find it. So the base is 11.6. I can times that by the height, which is 14.28, and then divide that by 2. So when I then do that, so 11.6 times 14.28 divided by 2 gives me 82.824. That's the area of the front. I then need to times that by the depth, because in this case it's a triangular prism, so that's why I've had to do the divided by 2, times that by 15.3, and you'll get an answer of 1,267.2072 centimeters cubed. And it says give your answer to 2 decimal places, so the 7 would round that up to a 1, so it's 1,267.21 centimeters cubed. Okay, so really important there that you understand. If you're missing that perpendicular height, do not use the slanted height there for the area of the triangle at the front. Okay, next one, moving on to a bit of reflection. One of the transformations that's very likely to come up comes up every year pretty much, one of the transformations anyway. So just be aware what to do here. So it says reflect shape A in the line y equals x. The line y equals x is a diagonal line. So you need to make sure you understand how to draw that diagonal line. Now what we're assuming in this is that each one of these squares represents 1, going up and back. So the diagonal mirror line would actually go in this direction here. Okay, so that is the line y equals x. If it was y equals minus x, it would actually go this way. Okay, so it's really important that you understand the difference between the two. That's y equals x. So I've drawn that line, I'd get a mark. So it says reflect shape A in the line y equals x and label it B. To reflect this, what you then do is you pick this point here and you think to yourself, how do I get from there to my mirror line? Well, I go 1.5 squares away. So what you then do is carry that on, you go half and 1. So that red point now moves to there. You then pick another point on the shape. Let's go for this one. And for me to get from there, I go 1, 2.5. So you go a half, 1, 2. And you end up drawing that line, that point there. And the final one here, I've got to go diagonally through lines 1, 2, 3 diagonal lines to get to the mirror line. So I go 1, 2, 3 diagonal mirror lines to get over here. And then all you do, join those 3 points up. That now is my shape B. It then says reflect shape B in the line y equals 1. Here, this crosses the y-axis at 1. So it's really important you understand that. It crosses the y-axis. This is my y-axis, which means the line y equals 1 goes across here. Okay, so that's the line y equals 1. If I was then going to reflect this line, this shape B in that mirror line, what I do, that corner is 1, 2, 3 away from my mirror line. So it goes 1, 2, 3 away. So that red point ends up there. This turquoise point down here in the bottom left, 1, 2, 3, 4, 5 away. So I go 1, 2, 3, 4, 5. So that ends up there. And the blue point, 1, 2, 3 away, 1, 2, 3. So that ends up there. And I redraw my shape there. And it says to label it C. So I've labeled it C. What it might then ask you to do is it might ask you to describe how you get from A to C. Now moving from A to C is clearly a rotation. You would then just need to go through your process on rotation and how you get from A to C, finding your center of rotation. Is clearly a 90 degrees movement clockwise. You then have to figure out where to go from. Okay, so that's an example of reflection, but you could also then link rotation into it as well. Okay, question 14. So what we're looking at is vectors. So it tells me the vectors for A and B are shown below. So A is equal to 7, 2. And what that basically means is if I was to pick a point, that means I go 7 right and 2 up. If it was a minus 7, it'd be left. If it was a minus 2, it'd be down. So that's basically saying to me, I go 1, 2, 3, 4, 5, 6, 7, 1, 2. And that would be my final point. I draw a line between the two, join them up. That's what A would be. And then it's saying to me B is actually minus 3, minus 4. So if I started there, I'd go 1, 2, 3 left, 1, 2, 3, 4 down. That's where I join it up to, draw a line. That's called B. So that's what a vector actually looks like. That's what a vector actually does. What it's now saying to me is to work out 2A minus 3B. The exam question might actually ask you to draw one. So if it does ask you to draw the vector, that's what you would do. Or that's what you would do for that one. Just make sure it does have an arrow on it based on what direction you've gone in. But in this question, all it's asking me to do is to work out 2A. Well, if I know that A is 7, 2, okay, all I need to do is times that by 2. Times the top by 2 and times the bottom by 2. So 2A is equal to 14, 4. That would get you a mark straight away. And then it's asking me for 3B. Well, B is minus 3, minus 4. Times that by 3, top and bottom. So it becomes minus 9 and then minus 12. So that's 3B. So that would effectively be 1 mark for doing that or that. Now from here, all you need to then do is write out this sum as it is. So 2A, well 2A is 14, 4, minus 3B. Well 3B is minus 9, minus 12. What you need to be careful of is the fact that you've got a couple of double negatives in here. So it's really important you follow the process and you just go through it carefully to not make any mistakes. So if we look at this then, it's saying 14 minus 9, which actually means 14 plus 9. And when you do 14 plus 9, you'll end up with 23. Okay. 4 minus 12 means 4 plus 12. That ends up giving you 16. So your final answer to 2a minus 3b would be 23, 16. Okay, so just make sure you're really careful with those negatives and you pick up those marks on scaling up the vectors, which is what we've done there. Okay, right, question 15, moving now, is relatively simple. It's just a case of making sure that you take your time over the expansion. So outside times the first inside, so that becomes 8x. 8 times minus 3 becomes minus 24. So that's important that you do that bit right. Minus 2 times x is minus 2x. And then minus 2 times plus 7, that's a minus 14. What I suggest you do is just go back and double check yourself. 8 times x, 8x. 8 times minus 3, minus 24. Minus 2 times x, minus 2x. Minus 2 times 7 is minus 14. That's definitely 1 mark. And then from here, it's just a case of collecting your like terms. That x, that minus 2x. So 8x minus 2x is 6x. Minus 24 minus 14. Be really careful there. It's basically telling you it's minus 24 degrees outside. It gets 14 degrees colder, which means it's going to become minus 38 degrees. Okay, just be really careful with those double negatives when you have a question like that. Okay. The next one then is just an expansion again, but it's slightly different because there's no add or subtraction between them. This will expand to give you a quadratic, and what we use here is the moon method. So x times x is x squared. X times minus 7 is minus 7x. 3 times x, which is plus 3x. And then 3 times minus 7, minus 21. So call it the moon method because that gives you a moon shape. That's 1 mark. Now you need to collect your like terms. When you collect your like terms, it becomes x squared minus 7x plus 3x. So it's minus 7 degrees outside. It gets 3 degrees warmer, which means it's now minus 4 degrees. And then minus 21. So that would be your final answer for the expanding and simplifying part there. So question 16 here, you can see I've got the calculator up ready already because what we've got is some compound interest stuff. So we're going to need the calculator for this. So 2 banks offer different interest rate for the 5-year savings account. So we've got Nat East, 2.8% compound interest when you invest for 5 years, and Halifax, which is 5% simple interest for 2 years. And then 1.5% compound interest for 3 years. So there's a bit of a difference here. We've got simple interest and we've got compound. So Barry's got £5,000 to invest for 5 years. Which bank should he invest in to get the best return? So the first thing you're going to do is when you've got something like this where there's 2 options, split your page in half and end up having one side where you're working out for one bank and the other side where you have your working out for the other side. So we know we're going to be starting with £5,000. So £5,000 is what we're starting with in both instances. Let's do Nat East first. Nat East first. So 2.8% compound interest. Now, you need to times this initial amount. So compound interest is the amount times the single multiplier to the number of years as a power. Okay. Now, to find the single multiplier, what you do is you do 100. If it's increasing, because it's compound interest, you add the percentage, so it's 2.8%. Which becomes 102.8%, and you divide that by 100 to get 1.028. So that's my single multiplier for this. That would get you a mark for understanding that you know what the single multiplier is. And then I'm investing it for 5 years, so it becomes a power of 5. So on your calculator, you then go 5,000 times 1.028. Please make sure you don't put 1.28 there, okay, because 1.28 is actually 28%. To the power of 5. When you write that down, you end up getting, you can see there, £5,740 and 31p. Okay, so that's how much Barry would get if he put the money in Nat East. I'm just going to rub all that out. So that's the first bit. I worked out the first bank and how much I'd get. So now what I need to do is think about this. Is 5% simple interest for 2 years. So this is slightly different. With simple interest, what you do is you still think about single multipliers, but we're going to think about it in a different way. I need to find 5% of that amount. So I'm going to find 5% of 5,000. Now there's a couple of ways you could do that. You could either do 5,000 times 0.05, because that's 5%, or you could find 10% by dividing by 10, which would be 500, and then 5% you could divide that by 2 to get 250. Okay, either way you still get 250, as you can see there. So 5% is 250. Now with simple interest, however many years it is, you then just times that by 2. So £250 for 1 year times it by 2 is £500 simple interest he's getting for the 2 years. So his £5,000 is now £5,500 because for 2 years he's added that interest added on. It then says 1.5% compound interest for the next 3 years. So from here, what I then need to do is take that £5,500, because that's my new amount. Remember, it's the amount times a single multiplier to the number of years. So my single multiplier is now going to be on that 1.5%. So it's 100 plus 1.5, which is 101.5. Divide that by 100, 1.015. So my single multiplier for this value here is then 1.015, and it's for 3 more years. So all I do is go to my calculator. So it's 5,500 times 1.015, and it's to the power of 3, which gives me £5,751 and 23p, as you can see there. So when I put it into Halifax, I end up getting £5,751 and 23p. If I put it into Nat East, £5,740. So for your final mark, because it says here, which bank should he invest in, you need to make a statement to say Barry should invest in Halifax, because it's going to give him the most amount of money. You need to make it really clear to that for that final mark in your exam. Okay, so really clear there. That ends up getting him an extra £11 on top of what he would have been getting if you put it into Nat East, roughly 11. Okay, right, moving on now, we're going to do some trigonometry stuff. So question 17 is asking me to find the value of x. Now, the reason I know that this is trig is because it's got angles involved. Okay, so anytime you can see angles, you know you're going to use trigonometry. Now with trigonometry, you're writing out your ratios. So however you remember it, sand on holiday can affect health till old age. It's a good one for me. That's how I remember it. And then from there, you label the triangle. Well, if this is my angle, that becomes my opposite. The longest side is always the hypotenuse. That side's my adjacent. I'm trying to find the opposite, so that's important. I've got the adjacent, so that's important. And therefore, the hypotenuse is not important. So where the hypotenuse is not important, I can't use that, and I can't use that. So I'm going to use tan. All I then do is treat that as a formula triangle. I write down tan, and I've got the angle, so 65. The opposite in this case is x, because that's what I'm trying to find, and the adjacent is 4.7. What you then do is you cover up x, and you're then doing tan 65 times 4.7. So on my calculator, just go to tan, type in 65, and then times by 4.7. You get an answer of 10.079. So if it would ask you to round it to one decimal place, that would be 10.1 centimeters. Okay, and that would be your answer to that trigonometry question. Okay, right, next one then, just going to make this bigger so you can see it. Next one here is question 18. We're looking at estimating the mean. So when you see something like this, where it's got inequalities here, so this basically tells you that 30 to 36 minutes, it was 3 people that took between 30 and 36 minutes to run this race. Now it means it's less than 36, so technically it's 35 minutes and 59 seconds. But that means that they were fit in there. So these 3 people were between these 2 times here. We don't actually know how long these 3 people took. We don't know how long these 17 people took, and we don't know how long these 12, etc., etc. took. So what we have to do is, the reason that this is an estimate is because we don't know the exact time these people took. So when you're asked to estimate the mean, with a question like this, you need to find the midpoint of each group, and then you need to times it by the frequency. Okay, now explain why. So the midpoint of this between 30 and 36 is 33. So what we're assuming is these three people took 33 minutes, so therefore we have to times that by 3 to get an answer of 99. So the total of their times would be 99. I'll then do the same for the next one. So between 36 and 42. So you can see that it's still a difference of 6. So that's going to be 39. So if you're not sure on how to find that midpoint, 36 to 42, the difference between 36 and 42 is 6. And then half that, which is 3. And then you're just adding on 3 to that. Okay, so 39 times by 17. And when you work that out, you get an answer of 663. The next one, again, difference of 6, just double check that the difference is the same. So that becomes 45 times by 12. So 45 times 12 gives you 540. Then we're doing, again, difference of 6. So that becomes 51 times by 8. And you get 408. And then the last one, the difference between 54 and 60, again, a difference of 6. So 57. And then we're timesing that by 2 to get 114. Okay, so your first step is to just work out midpoint of each group and times it by the frequency. Once you've got all of these, you then add those together because this becomes your total. When you think about mean is all of it added together. So it's the total of all data divided by the number of pieces of data. Now, if you think about that, all of these numbers here is the total of all the time. So then I do 99 plus 663 plus 540 plus 408 plus 114. And when you add all of that together, you get 1,824 minutes. So this becomes my total time. Now, what you then need to do is to find the mean. That's my total of all the data, so 1,824. And remember, that's an estimate. That's not exact. Assuming that these three people took 33 minutes. So that's why this becomes an estimate. And then you just need to divide that total by how many people there are here. Now, be really careful here because a common mistake is people divide it by 5 because there's 5 groups. So what you then need to do is add all your frequencies together. So that gives you 20 plus 12, so 20 plus 12 is 32, plus 8 is 40, and then that's 42. If you want to double check yourself, actually type in 3 plus 17 plus 12 plus 8 plus 2, and that is a total of 42 people. So then I'm doing 1,824 divided by 42, and when I do that, I end up with an answer of 43.4. So this is what I'm saying is my approximate mean. So it's an estimate for the mean, the time it would take them to run that 10K. Now let's look at where that would sit in this group. Now that would sit in here, which is not a million miles away from where the median would be. Okay, so actually that makes sense. My answer here makes sense because it fits into this table. If you end up having an answer of, say, 500 and something, then it's obviously not going to work because none of that is in the 500s. Okay, so that's an example of estimating the mean. Just make sure you do midpoint times frequency, add it all up, and just remember divide it by the total frequency. So all of that added together and not divided by 5. Okay, right, last couple of questions now. We're on to question 19, which is solving simultaneous equations. So with simultaneous equations, the first thing you want to do is look at making something the same. Now I'm going to talk about making the y's the same. Okay, now if the y's are already the same, then you can skip this first step, but if they're not, this is what you need to do. So the first thing is I look at it, I've got a 3y and a 7y. Well, how can I make them both the same? And the answer is to make them to 21. If you're ever stuck, you just multiply it by the opposite one. So where this is 3, I multiply it by 7, and where this is 7, I multiply it by 3. Now I'm going to ignore the fact that it's negative and positive. I'm just going to write a times 7 next to it there, and underneath here, I'm going to write a times 3. So the most important thing here is you are multiplying the whole thing by that number. So 7 is what I'm multiplying the first one by. So I do 4 times 7, which is 28. So that becomes 28x. Minus 3 times 7 becomes minus 21y. And then 47 times by 7 gives you 329. So I've now made all my y value to 21. I do the same on the bottom. So I'm going to do 3 times 3, which is 9x, The 7y times 3 gives me my plus 21y. So now you can see my y's are the same. And then 3 times minus 11, which is minus 33. Just be really careful. A lot of the time what pupils do is they forget to multiply one of those parts. So if you're multiplying it by 7, you're multiplying the whole lot by 7. Now that ends up getting you a mark, first of all. So we picked up a mark because we've scaled up, or we've made our y's the same. Now, shortcut here, a trick is to use this acronym of STOP. You're looking at the signs. Now the signs I'm looking at are the ones that are in front of the y, because that's what I've made the same in terms of the number. So this is to do with the signs. Okay, are the signs here the same? If they were, I would then take away. If the signs are opposite, then you plus. So looking at this, these two signs are opposite, so I put a plus sign next to it. So this is my shortcut to help me understand how to eliminate these y's. So then I'm doing 28 plus 9 to get a total of 37x. Minus 21y plus 21y cancels that out, so that's why my y's disappear. And then what I'm now doing is 329 plus minus 33, which gives you 296. When you've got a positive and a negative together, it subtracts. Then your last step here is to rearrange this, so you take the 37 over and it becomes a divide by 37. So x is equal to 296 divided by 37, which ends up giving you 8. So that's your second mark there. And your final step is to take that 8. You're saying x is 8. You go back to this first equation that you've done. So the 4x minus 3y equals 47. Or you could use the second one, it doesn't matter. And you change x for 8. So I'm now going to say 4 times by 8 minus 3y equals 47. Well, that gives me 32. 32 minus 3y equals 47. Now I need to rearrange this again because I'm trying to get y on its own. So I take the 32 over, it becomes minus 32. So minus 3y is equal to 47 minus 32, which is 15. And then your final step here is to get rid of that minus 3. So it's a divide by minus 3, so it becomes y is equal to 15 divided by minus 3, which means I'm going to end up with a negative value. So 15 divided by minus 3 is minus 5. So y is equal to minus 5. Now, if you wanted to double check yourself, what you can do is take both those values and substitute into the bottom equation. So if we look at that purple one, 3 times x, well, x is 8, so 3 times 8. Then I'm saying plus 7 times y, well, that's 7 times minus 5. And it should give me minus 11. Let's work that out. So that's 24, and then 7 times minus 5 is minus 35, and 24 minus 35 is minus 11. So I've checked my answer. I know it's correct. Okay, so that's simultaneous equations. Just remember that acronym at the side there, STOP, and it will help you to figure out what to do there. Okay, on to the last question, question 20. Here we go. So if we begin to break down this question, it says an ice cream company needs card coverings for their cornetto ice cream. The diagram shows the dimensions of each cone. A box of ice cream cones is sold in packs of 6. So we've got a box of ice cream cones sold in packs of 6. That means one box, so I'm going to write that key piece down, equals 6 cones. Each cornetto has a card covering for the top. Right, so basically we need to understand what area of maths this question is. Now you can see here I've been given two formulas. I've got the surface area of a cone and I've got the volume of a cone. So I need to decide which one this is going to be about. Now because this is talking about covering the outside of the cones, this is to do with surface area. Okay, so what this is basically saying to you is, can you work out how many centimeters squared is going to be needed for one cornetto, and then basically times it by 6. So if we look at that, then it says here to work out the surface area of a cone, it's pi r squared part is the area of the bottom. Okay, so that's what that bit is referring to. So if we think about our cone here, imagine a cornetto cone. That bit there is the pi r squared, that's the area of a circle. Then the pi r L is actually, what we're talking about is this outside bit here. It's the bit of the cone that would be on the outside, so that bit of paper that would cover around the outside. So that's the curved area. So looking at what we've got here, we can do pi r squared quite easily. So pi times the radius in this question is 3. So pi times radius squared. Now if I just keep this in terms of pi to make it easy, that gives me 9 pi. And I'm going to label what that is. That's the area of the bottom. Okay. So in this case, that is the card covering for the top Okay, then I need to do the pi times the radius is 3, and then times by the length, which is 7.62. So this is where you're obviously going to need to use your calculator to do that bit. So when you do pi times 3 times 7.62, you will get, that gives you 71.8168 centimeters squared. So this bit is the curved bit. Okay. What I now need to do is I need to think to myself, I want to add both of those together. So let's just turn 9 pi into a number which is 28.27. So it's 2743. So that is the area of the bottom. That is the curved bit. So we need to add both of those together, and that will give me one cone. So 71.8168 plus that 28.27 gives you bang on 100.09. So 100.091 centimeters squared. So that's one cone. So one cone needs that much paper, 100 centimeters squared of paper, and basically it's saying to me how many centimeters squared of paper is needed for one box, and we know one box is 6 cones, so I then very simply times that by 6, and you end up with 600.5468 centimeters squared, which effectively you could call 600.5 centimeters squared. It'd probably tell you what's rounded to. Okay, so that's a really good example there if you need to figure out whether or not it's asking you for volume or if it's asking you for surface area. In this case, it's very clearly asking you for surface area because we're talking about the outside and covering these cones. Okay, if we just go back then to the beginning of what we've done, so this is what we've covered in this. It's really important that you go through these and make sure you're happy with all these topics. They are topics that could very well come up in the exam, not necessarily in this exact style, but just in a particular way they could come up. But if you understand the fundamentals, you could answer it based on whatever style of question you get. So I hope that's helped you. I hope it helped you towards your exams. Good luck in your exams, and I'll see you all in the next video.